Example 1, find log 15 base 6. So we can represent log 15 base 6 as x. Remember the system of changing the logarithmic to index form. If x equals log 15 to base 6, then 6 raised by x is equal to 15. Now the next step is to take common logarithm of both sides. That is, log 6 raised by x equals log 15. And log 6 raised by x means x log 6. X goes to the back. So to find x, we are going to divide both sides by log 6. And that will be x equals log 15 over log 6. Now let's check the log table for log 15 and log 6. To determine the logarithm of 15, simply check for 15 under 0, and that gives you 1761. To find the logarithm of 6, simply check for 60 under 0, and that gives us 7782, with the integer or characteristic of the logarithm being 0. That means we are going to have 0.7782. From the table, log 15 gives us 1.1761, and log 6 gives us 0.7782. When you simply divide using your calculator, what we get is 1.511, 1.511. But let's use the number log method to evaluate this fraction. And we shall see if we are going to get the same answer, which is 1.511. For 1.1761, there is only one number before the decimal point. That means the integer is 0. And for this second number, the number starts with 0 dots, and the integer will be bar 1. Take note. Open the log table again and check for 11 under 7 difference 6. Also check for 77 under 8 difference 2. To find the logarithm of 1.1761, simply check for 11 under 7 difference 6. Now 11 under 7 gives us 0.682, difference 6 gives us 23. Add together, and that comes to 0.0705. To find the logarithm of 7782, simply check for 77 under 8 difference 2. Now 77 under 8 gives us 8910. Check difference 2, that is 1. Add 1 to 8910, and that is 8911. Log table. From the log table, the value we got for the first check is 0.705. And for the second check, the value is 8911. As we subtract under the law of division, so 5 minus 1 gives us 4. Borrow 1 from 7, that remains 6. 10 minus 1, that gives you 9. Borrow 1 from 0 here, that will remain minus 1. When the 1 comes here, you have 10. Borrow 1 from that 10, it remains 9 here. 6 was left here before, now we have 16 minus 9 giving you 7. 9 was left here, 9 minus 8 gives you 1. Minus 1 was left here, so minus 1 minus minus 1 gives you minus 1 plus 1, and that is 0. Now let's open the table, that is the antilog table. So check for the antilog of 17 under 9 difference 4. To find the antilog of 1794, simply check for 17 under 9 difference 4. 17 under 9 gives us 1510. Check difference 4, that is 1. Add 1 to 1510, that gives us 1511. From the antilog table, we got 1511. And since the integer part is 0, that means we count one digit and put point. So we have 1.511. So this method can be generalized as follows. Suppose x equals log n base m. If x equals log n base m, change it to index form, and that will give you m raised by x equals n. Take common logarithms of both sides, and that will be log m raised by x equals log n. Remember, log m raised by x means x log m. The power x coming to the back of the log, and when we divide both sides by log m, x will be equal to log n over log m.